Welcome to this explainer. Today, we are going to embark on a real cinematic journey into the deepest, most mysterious mechanics of space-time. You know, we so often look up at the night sky and just marvel at the sheer, unimaginable scale of the universe. But honestly, that same scale is also deeply frustrating. Think about it. Even if our most powerful telescopes find a perfect, Earth-like planet out there, the vast cosmic ocean between us just seems absolutely impossible to cross. So today, we're exploring what might just be the ultimate cheat code of the universe.
So why are we so desperately searching for cosmic shortcuts in the first place? Well, let's take a look at our closest galactic neighbor, the Andromeda Galaxy. It is impossibly far away.
Specifically, we are talking 2.5 million light-years away. To put that massive number into perspective, if we boarded a standard spacecraft today, traveling at roughly 28,000 kilometers per hour, it would take us 94.5 billion years to reach Andromeda. And hey, even if we magically developed the tech to travel at the absolute speed of light, it would still take 2.5 million years. When you really look at the raw numbers, traditional intergalactic travel seems utterly hopeless. I mean, what's the point of discovering all these new worlds if we're forever trapped in our own tiny little corner of the Milky Way?
Section 1. The ultimate cosmic shortcut. This kind of existential despair brings us to a really incredible theoretical beacon of hope. You've probably seen it popularized in movies like Interstellar, but the concept of the wormhole isn't just science fiction. It's actually grounded entirely in rigorous physics. Now, there is a massive misconception out there we need to clear up. A real wormhole wouldn't be a flat circle like a manhole cover. Because we live in three-dimensional space, it would actually appear as a glowing spherical portal. Step inside, and the entire fabric of the universe literally bends and warps behind you as you travel through this incredible tunnel of warped spacetime.
Moving on to Section 2, Bending the Space-Time Fabric.
To really grasp how a spherical portal could just exist out there in the dark, we have to look back at the mathematical genius that completely redefined our universe. Back in 1915, Albert Einstein published his general theory of relativity. He introduced 10 highly complex differential equations. And these equations were so profound that scientists mathematically predicted a century of mind-bending phenomena, like black holes and white holes, long before a telescope ever even observed them. To explain this super complex math to the world, Einstein used this absolutely brilliant visual. He told us to stop thinking of gravity as just some invisible magnetic pull. Instead, imagine reality itself is a vast flexible mesh, the actual fabric of spacetime. When you place a heavy object, say a star or a massive planet, onto this mesh, its immense gravitational weight actually bends and curves the physical space around it.
Section 3. The Einstein-Rosen Bridge.
Okay, so in 1935, Einstein was working alongside his assistant Nathan Rosen, and they took this idea of a bending spacetime mesh to its absolute extreme. They realized that under intensely extreme gravitational conditions, this mesh could fold entirely over onto itself. And guys, this is the formal, scientific reality of what we casually call a wormhole, the Einstein-Rosen Bridge. It is a completely valid mathematical solution. It describes a tunnel connecting two completely disparate, impossibly distant points in spacetime, potentially bridging billions of light years in an instant.
Think about it like this. If you want to fly from Delhi to New York on a flat 2D map, drawing a straight line makes you think flying over Africa is the shortest path, right? But the Earth isn't flat. When you step into a 3D reality, you quickly realize the actual shortest route is curving way up north over Finland and Greenland. Just as adding a third dimension completely redefines the shortest path on Earth, folding our 3D universe into a fourth-dimensional space creates these epic cosmic shortcuts we couldn't otherwise perceive.
This whole concept was honestly so mind-boggling that scientists needed a simpler way to talk about it. In 1957, physicist John Wheeler actually coined the term wormhole using a super elegant analogy. Imagine an apple's surface is normal space. A bug crawling along the skin has to travel the entire circumference just to get to the bottom. But a worm? A worm simply eats straight through the core, bypassing the surface entirely, and emerges instantly on the exact opposite side.
Sounds like the perfect cheat code, right? Well, actually, here's where the science gets incredibly dark. To puncture that hole in reality, you need the immense, crushing gravity of a black hole. Plus, without a highly theoretical substance called exotic matter just to prop the tunnel open, the bridge would instantly collapse and completely crush any ship inside. And even if it magically stayed open, a black hole is a one-way trap. Nothing escapes it. So how in the world do you ever get out?
Which brings us to Section 4, Black Holes versus White Holes.
If our spacecraft is going to survive this epic journey, the exit of the tunnel simply cannot be another black hole. For the bridge to be traversable, it needs a mathematical opposite. Enter the white hole. This concept was introduced by Russian physicist Igor Novikov back in 1964. The idea is, if a black hole has an event horizon of absolute no return, a white hole has a boundary of absolute no admission. Literally nothing can enter a white hole. It's intensely bright, practically blinding, and instead of sucking reality in, it violently ejects matter and light out into the universe. It is basically the perfect cosmic exit door.
Now, I know what you're probably thinking. White holes sound completely made up, but they actually solve a massive problem in quantum physics. Building on Stephen Hawking's theories regarding black hole evaporation, there's this fundamental rule called the no-hiding theorem. Basically, information in the universe cannot just be deleted. So when a black hole eventually dies and evaporates, everything it ever consumed has to go somewhere. A lot of physicists argue it gets spit back out into reality, likely via a white hole.
And here's the absolute craziest part. We might have actually seen one. Now, white holes technically violate the laws of thermodynamics because they reverse entropy, which is kind of like watching an explosion perfectly reassemble a shredded piece of paper. Yet, on June 14, 2006, the Swift Observatory detected an unimaginably brilliant flash of light. Usually, a gamma-ray burst happens when a black hole eats a star, but in this case, there was absolutely no star involved. It was just a massive, completely unexplained cosmic flash of light out of nowhere, leaving scientists seriously wondering if they had just witnessed a white hole tearing open the fabric of space.
All right, Section 5, the Magnetic Lab Wormhole.
While epic cosmic wormholes remain frustratingly theoretical, science has a really remarkable way of dragging the impossible down to Earth. In a truly spectacular breakthrough in 2015, researchers constructed an actual, specialized lab device that acted as a literal wormhole. Now, not for a spaceship, obviously, but for magnetic fields. Using a high-temperature superconducting material called yttrium barium copper oxide submerged in a freezing liquid nitrogen bath, they achieved the impossible. Think about it. Every magnet has a north and south pole, right? Even if you snap it in half. But this device created an invisible tunnel that successfully separated the magnetic fields. A magnetic field entered one end of the device, completely vanished from detectable 3D space, and emerged out the other end. They literally warped reality on a microscopic magnetic scale.
Section 6. Warping reality with the Alcubierre drive.
So, what if stable, human-sized wormholes, which require vast amounts of negative energy and exotic matter, just prove genuinely impossible to build? Well, we don't have to give up on the stars. Einstein's field equations offer one more mind-bending avenue, the Alcubierre warp drive. Proposed in 1994, this idea absolutely staggers the imagination. Instead of punching a hole through space, what if we just shrink the space in front of us? This solution suggests a ship wouldn't actually fly through space at all. Instead, the ship sits perfectly still in a protected bubble, while the drive forcefully contracts the space-time curvature directly in front of it and violently expands the space-time curvature directly behind it. The spacecraft essentially surfs a manipulated wave of reality. This would allow us to arrive at our destination faster than light without ever breaking the universal speed limit.
I want to leave you with this final thought for today's explainer. For nearly a century, black holes were considered just a mathematical quirk, a theoretical fantasy on a chalkboard. And then we photographed one. If the exact same math that predicted black holes also predicts Einstein-Rosen bridges, white holes, and warp drives, what other impossible realities are just waiting out there in the dark, waiting for us to catch up? The universe is deeply, deeply strange, and our journey to understand it is honestly only just beginning.